Hi all, welcome to our class. We have studied the chapter Trigonometry. In this chapter, we are going to study some applications of trigonometry. So, in this chapter, we will see how trigonometry is used for finding the height and distance of various objects without actually measuring them. So, let us consider a tower, a person who is standing here watching the top of the tower. So this is the line of sight. So first we are going to study angle of elevation. Angle of elevation. We have to study two topics: angle of elevation and angle of depression. Two topics we have to study: angle of elevation and angle of depression. So angle of elevation means a person who is standing here, who is watching the top of the tower. Let us consider the horizontal line. This is the eye of that person. This is the horizontal. We consider this as horizontal. Then this is line of sight. So when we consider this, a person who is watching the top of the tower, this is the horizontal line. This is here his eye, and this is line of sight. So he is watching the top of the tower. So when we consider this is the side, this is also underside, and consider a right triangle. So in trigonometry we use right triangle. So we will get a right triangle. So when we see the top, here an angle formed. That is called angle of elevation. So we will also get a triangle. So when we consider this is a line. So this is a right triangle at 90 degree here. So this angle, this is called angle of elevation. So when this is the person who is seeing the top, then this is the horizontal. The angle between line of sight and the horizontal, that is called angle of elevation. Then next one is angle of depression. Suppose that in this example, a person who is standing here, he is seeing an object in the ground. Here an object. So a person here, he is standing an object that is distant from the tower. So this is the line of sight. So when a person sees that object, so this is the horizontal, that is the line. This is this eye, therefore this is the horizontal. So he is watching an object. So we can draw the line. So this angle, he is watching that object. When we can draw straightly. This is the object he is watching. So the angle between this horizontal and this line, this is called angle of depression. So this is the horizontal line, this is the line of sight. So this is called angle of depression. So two things we have studied: angle of elevation and angle of depression. A person who is watching the top, this is horizontal, then this is the line of sight. The angle between line of sight and the horizontal line is angle of elevation, and this is the horizontal, this is the object, this is the line of sight. So the angle between these two is called angle of depression. So using these two concepts, we can easily find the height of the tower, also the distance between the foot of the tower and the object. All these things we can easily find using this concept. So angle of elevation and angle of depression. Let us discuss one question. A tower stands vertically on the ground from a point on the ground which is 50 meters away from the foot of the tower. The angle of elevation of the top of the tower is found to be 60 degree. Find the height of the tower. So we have a tower. Then a tower stands vertically on the ground from a point on the ground which is 50 meters away from the foot of the tower. So from a point, this is the ground, from a point 50 meters away from the top, from the foot of the tower, the angle of elevation of the top of the tower is found to be 60 degree. So let us consider this is the point 50 meters away from the foot of the tower. The angle of elevation of the top of the tower, this is the top of the tower. The angle of elevation is found to be 60 degree. The angle of elevation found to be 60 degree. So this is 60 degree. Angle of elevation found to be 60 degree. Find the height of the tower. So this is 15 meter. That is, this is the object. Then this is the point. Sorry, this is the point. That is 50 meter away from the foot of the tower. Found to be the angle of elevation. This is horizontal and this is the top of the tower. So angle of elevation is 60 degree. So we have to find the find the height of the tower. So this is the tower. We have to find the height of the tower. So we have a right triangle. So we can apply the results of trigonometry. So we have to find this height. So this is ABC. This is ABC. Right angle at B. So we have a right triangle. This is 15 meter. This is 60 degree. We have to find the height of the tower. So I am going to take this as H. Height is equal to H. We have to find AB. So we have to find AB. BC is equal to 50 meter. Then angle C is equal to 60 degree. So this angle, and we know this side, we have to find this side. So angle is this, angle C. This is the side adjacent to angle C. We have to find the height. So we have the relation between this angle, this side and this side. This is adjacent side, this is opposite side. So which trigonometric ratio is applicable for writing with the adjacent side and opposite side? We know tan and cot. Tan theta is equal to opposite side by adjacent side. So using that result, we can easily find the height. So we know tan 60. Tan 60 means opposite side by adjacent side. That is AB by BC. AB by BC. So tan 60. This is 60. So BC is side adjacent. Therefore BC is here. AB side opposite, that is AB. So tan 60 is equal to AB by BC. Tan 60, we know the value of tan 60. Tan 60 is root 3, which is equal to AB. We have to find AB, that is H, and BC. BC is 50. Therefore root 3 is equal to H by 50. Therefore H is equal to cross multiplication 50 root 3 meter. So the height of the tower is 50 root 3 meter. So using the trigonometry, we can easily find the height of that tower. Another question: an observer 1.5 meter tall is 28.5 meter away from a chimney. The angle of elevation of the top of the chimney from her eyes is 45 degree. What is the height of the chimney? So we have a chimney. Let us draw that chimney. Okay. Suppose that this is the chimney. An observer, this is the ground level. An observer 1.5 meter tall is watching the top of the chimney. That is, this is the horizontal line. and this is the, he is scratching the top of the chimney. So with an angle of elevation 45 degree. So angle of elevation is 45 degree. So we have to find the height of the chimney. So we have to find the height of the chimney. So let us consider a right triangle. So we have to find the height. So let us mark the points A, B, C, D, E. So we have to find the height of the chimney. Height of the chimney means AC. Height. We have to find the AC. We have to find AC. So we know AC means this is horizontal, up to horizontal level is AB. Then height of the man, that is same as BC. That means AC is equal to AB plus BC. AC is equal to AB plus BC. We know BC, that is AB plus 1.5 meter. That is ED is equal to BC, that is height of the man. Therefore, AB plus 1.5. So we have to find AB. And we know the distance is 28.5. So this is 45 degree. This is 28.5, and we have to find AB. So this is angle 45 degree. This is adjacent side, that is 28.5, and we have to find AB. So we have to find tan 45. That is adjacent side and opposite side. Relation between adjacent side and opposite side, that is tan. Therefore we take tan 45. If hypotenuse and opposite side, we use sine. Adjacent side and hypotenuse, we use cos. Here adjacent side, here angle 45. This is adjacent side, that is given thing 28.5. This is opposite side, that we have to find. So opposite side, adjacent side, so we use tan. Therefore tan 45, which is equal to AB by B, DC or BE, that is 28.5. So tan 45 we know 1, which is equal to AB by 28.5. Therefore AB is equal to 1 into 28.5, that is 28.5. AB is equal to 28.5. So we have to find the height of the chimney. So that is AC. AC is equal to AB plus BC, that is AB plus 1.5. AB is 28.5. So which is equal to 28.5 plus 1.5. That is 28.5 plus 1.5, which is equal to 30 meters. So 30 meters. So the height of the chimney is 30 meters. So using the concept of angle of elevation, so 1.5, that is this height plus AB, that is total height of the chimney, that is 30 meters.